Hi, my name is Christian, and today we're going to be talking about variables and sets. This is the first video of my discrete mathematics course that I decided to work on. So, what is a set? Well, a set is just a collection of elements. It can be any kind of element, such as a dog, an apple, or the number 3. Here's another example of a set. 9, 3, 2, 8, 6, 4. These are all integer numbers, but notice how they're not in any particular order. This is because it doesn't matter whether a set is in order or not. You can also have a set within a set. Here is a set of sets. We have 1, 3 as a set, 2, 4 as a set, 0, 8, 9 as a set, and 6 as a set, all within one other set. 1, 2, 3 with an ellipse at the end indicates that this goes on forever. So it's the set of all integer numbers from 1 onto infinity. So you can do something similar with a range, where it's 1, 2, 3, and then we have an ellipsis, and then 100, which indicates that all numbers between 1 and 100 that are an integer. What we're doing here is called set roster notation. Set roster notation basically just specifying a set by writing all of its elements between braces. Now, we can go ahead and go over some notation. If we want to say that something is an element of a set, we can say that X is an element of S. And we can do this through some notation where X with a interesting little symbol here, meaning is an element of or is a member of, and then we have S at the right, which is a set. We can do something very similar to indicate that something is not an element. So if S is a set, X is not an element of a set. Again, it's very similar, except we have a slash to indicate that it's not an element of a set. Here is an example. If C is the set of all states in the US, then Texas is an element of C. To write this in a more mathematical way, we can say Texas is an element of C, where C is the set of all states in the US. If C is a set of all states in the US, then Dallas is not an element of C. To write this, all we have to do is say Dallas is not an element of C. There are some sets of numbers that are very prevalent that we use very often, so we have special symbols for them. The first one of these is the set of all real numbers. This is denoted by the symbol R, and notice how it's a special kind of symbol. It looks differently when you write it by hand, but just know that this is what it looks like on the computer. Same for the set of all integers. The set of all integers is denoted by a Z, a special kind of Z. And then we have the set of all rational numbers, which is denoted by this special Q. Note that a rational number is just a quotient of an integer. Okay, now we can start talking about set builder notation, which is a bit different from set roster notation. So set builder notation will look something like this. So we have the set of all elements X and S, this is the blue, such that, that's what the vertical line means, P of X is true. Here's an example. We have the set of all integers such that 2 is less than X, which is less than 7. This gives us 3, 4, 5, and 6, because 3, 4, 5, and 6 are all integers that are between 2 and 7. Okay, so now we're on subsets. So if you can look at my picture right here, we have a little circle B, and then that's going to be inside a larger circle A. So we can think of B as a set where all of its elements are within A. So it shares all of its elements with A, but A has more elements because it's bigger, right? So set B is a subset of set A only if every element in set B is an element of set A. That's the definition of a subset. Okay? Now let's say we have a set A, which is 1, 2, 3, 4, 5, 6, and 7. We have another set B, which is 3, 4, 5, 7, and then set C, which is 1, 2. We can say that B is a subset of A with this notation, where it's like a sideways U with a underline. That would mean that B is a subset of A. And this is because 3, 4, 5, and 7 are all elements that are found within A, and there aren't any elements that are not in A. If we want to say that a set is not a subset of another set, we can just say, for instance, C is not a subset of B. And we can actually truthfully say this because 1 and 2 are both elements that are not within 3, 4, 5, 7, right? Within that set B. There's also such thing as empty sets, right? And an empty set is a subset of virtually every single set. So we have a little phrase here called a proper subset. And proper subsets are subsets that contain at least one element. Now on to quantifiers and conditional statements. Let's say we have a phrase such as, each class has an instructor assigned to it. We can say this in a more formal way. For each class X, there exists instructor Y such that Y teaches X. We have symbols for each and there exists, as found here. For each class X, there exists or there is instructor Y such that Y teaches X. These are called quantifiers. As for a conditional statement, it's basically if hypothesis, then conclusion. If the hypothesis is correct, then the conclusion must follow. Alright, so what is a Cartesian product? Well, a Cartesian product is just the set of all possible ordered pairs where the first element comes from one set and the second element comes from another set. So let's say we have A equals 1, 2, 3, and another set B which equals M and N. We could do something similar to FOIL. That way we can get 1 times M and 1 times N to get us our tuple. So A times B would be 1M and 1N, 2M, 2N, and then 3M and 3N. Alright, our next video is going to be on relations.